Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Is there another mysterious planet between Mars and Jupiter? NASA has now made an impossible discovery in our solar system that could prove just that. The idea that another planet exists somewhere in the asteroid belt between Mars and Jupiter is not new. As early as the 18th century, scientists found evidence of another planet that, from a purely mathematical point of view, should be right there. What new evidence has NASA now found? And does this planet really exist? Back in the 18th century, the German astronomers Johann Daniel Titius and Johann Elot Bode developed a mathematical rule stating that there must be another planet between Mars and Jupiter. Today, this idea, based on mathematical statistics, is known as the Titius-Bode rule. The two astronomers measured the distances of the planets from the Sun and established a certain order. According to this, there should be another planet where the asteroid belt is. In the 18th century, the publication of the theory led to an intensive search for this missing planet. However, only one object was found, and scientists are still not in complete agreement as to whether it is a planet or not. Ceres, with a diameter of around 940 kilometers. This small body in the asteroid belt is large enough to have a roughly round shape due to its gravity. But is this really the missing planet? Recent calculations say no. There must be, or at least have been, a much larger object at this location. Careful new analyses of planetary orbits, also with the help of modern astronomy, have provided evidence that there should actually be a planet in the gap between Mars and Jupiter. Since the discovery of the asteroid belt, there has therefore been some speculation about its true nature. Could the many hundreds of thousands to millions of chunks in this section be the debris of a larger planet? Asteroid belt or debris field? It's exciting to think that the asteroid belt is actually a debris field. Millions of objects caught here, probably bound by the gravitational pull of Jupiter. And we can be glad that the largest planet in the solar system binds all this debris to itself, because otherwise they would fly through the solar system as dangerous projectiles. The objects in the asteroid belt range from tiny grains of dust to larger bodies such as the dwarf planet Ceres. However, Ceres is an exception. So far, most of the rocks are typical asteroids with a diameter of a few meters to a kilometer or even significantly more. Asteroids are typically not round like this object, but rather misshapen chunks. Evidence that these are not asteroids but planetary fragments first emerged when scientists examined the region in detail and took measurements. They noticed an apparently chaotic distribution and a large amount of material in this belt. Computer simulations showed that the way the chunks are distributed does indeed point to a possible catastrophe. But what is strong enough to destroy an entire planet? Before we look at possible answers to this question, let's take a moment to consider what speaks against this idea. Many scientists are certain that so many rocks have accumulated in this region because Jupiter exerts an immense gravitational pull. This would therefore mean that Jupiter has bound many loose objects that were once distributed throughout the solar system to itself over the course of time, and that these objects did not form in this position. Analyses of the composition of various asteroids further indicate that these bodies have very different origins and formation histories, which argues against the theory of a single destroyed planet. Many asteroids have complex and diverse chemical compositions, but a hypothetical common planet of origin would have left behind fragments of similar composition. Most of the asteroids consist of mixtures of silicate rock and metals, as well as organic substances, and some are at least partially made of ice. All of this actually speaks against fragments of a planet. Gigantic collision in the cosmos. Was the asteroid belt once a planet? Can you even begin to imagine what forces would be necessary to destroy an entire planet and break it up into fragments? An unfortunate hypothetical planet could have been the victim of violent collisions, or it could also be possible to imagine unusual gravitational disturbances that could break a planet into pieces. One conceivable scenario would be a massive collision with another planet or very large asteroid. Such collisions were more frequent in the early days of the solar system, at a time when planet formation was still in full swing and space was filled with large quantities of protoplanetary material. The planets were often still tumbling through the solar system on chaotic orbits, and there were frequent collisions. One theory suggests that this is exactly how our moon could have been formed. Allegedly, a planet that no longer exists today collided with our Earth, and on impact, the mass was blasted off the still young, hot Earth, which later became the moon. So, could the fragments in the asteroid belt be the remains of this planet? We do not know. In the present day, this story of the origin of our moon is increasingly being questioned. Some scientists are of the opinion that the moons in the solar system also formed like small planets, and some of them could basically be similar structures to dwarf planets, but which were then bound to the gravitational pull of planets instead of making their own orbits around the sun. Size comparisons show very nicely that the largest moons in the solar system, such as Titan or Europa, are about the same size as the largest dwarf planets. And there are small dwarf planets that are not much larger than average moons. In terms of composition and shape, it's almost impossible to draw a line between moon and dwarf planet. But back to our hypothetical destroyed planet. A direct hit by another large body could result in a planet being literally torn to pieces. Computer simulations have shown that the kinetic energy of an impact can be enough to fragment an entire planetary body. The simulations further show that the debris could either have landed in the asteroid belt, others could have had so much force that they were thrown out of the solar system, and still others could have burned up in the sun. Another scenario that can break an entire planet into fragments is interaction with the gravity of a nearby and very massive object. This could have been another star passing through our system or a very large planet that was torn from its orbit. Such scenarios have probably occurred in the history of our solar system. For example, there is evidence that Neptune was once pushed to its outermost position by an orbit closer to the Sun. If an object the size of Neptune travels through the solar system, the pressure on other planets can be so great that either they also jump out of their positions or they are crushed. A third theoretical scenario that could destroy an entire planet is the accumulation of dark matter in the core of a planet. This, in turn, would eventually lead to an internal explosion that tears the planet apart from the inside out. Are the asteroids remnants of a prevented planet? Let's look at another exciting theory. Recent calculations by NASA scientists set out to prove that these rocks between Mars and Jupiter are not fragments, but rather building blocks of a planet that was never completed. According to this theory, another planet should actually have formed from the existing mass. These many chunks consist of primordial materials that once gathered in this place to actually form a planet. This idea corresponds roughly to the theory of the 18th century astronomers Titius and Bode. The forces may not have been sufficient to accrete the mass into a single body, for which Jupiter could be responsible. With its enormous mass, Jupiter exerts both binding and strongly disruptive influences on the asteroid belt. These disruptive forces could have prevented the objects from merging into a larger body. However, research has shown that the total mass of the asteroid belt is less than 1,000th of the Earth's mass. But this evidence does not necessarily contradict the theory, as the asteroids we might still see today could be only a fraction of their former mass. Computer simulations have shown that some of the primordial mass could also have flown into the Sun, and it's also possible that some or even all of the objects in the Kuiper Belt are also parts of an obstructed rocky planet. The Kuiper Belt is located behind Neptune and is home to several million more objects over a width of several 100,000 kilometers. Many scientists consider all these theories to be far too bold. Rather, they believe that all the asteroids, rocks, dust, and other objects in the asteroid belt are direct remnants of the formation of our solar system. But if this is true, how could an object like Ceres form in the first place? And what exactly is it? Is Ceres an asteroid or planet? Who would have thought that Ceres, which is now officially classified as a dwarf planet, has only 1/6000th of the mass of our Earth? This means that the mass of this mini-planet is even smaller than the total mass of all other objects in the asteroid belt combined, which is 1/1000th. In comparison, the dwarf planet Pluto also has only about 1/500th of the Earth's mass. A small planet could therefore have formed from the chunks in the asteroid belt. The question remains as to why Ceres remained so small at this point and did not accrete more material to grow into a larger planet. There would obviously have been enough material available. Incidentally, this question also applies to the many dwarf planets in the Kuiper Belt. They, too, have remained quite small, although there would have been enough mass to form larger objects. Ceres is a truly unique case in its position. It's definitely the largest single body in the asteroid belt and was discovered on January 1st, 1801, by the Italian astronomer Giuseppe Piazzi. Piazzi was searching for the missing planet and was initially unconvinced that Ceres, which is only around 940 kilometers in size, was really a planet. Due to its size and mass, Ceres has sufficient gravity to have a round shape. This characteristic is typical of planets and led to this object being classified as a planet for a time after its discovery. Over time, and with the discovery of other similar objects in the asteroid belt, Ceres was then downgraded to the category of an asteroid and later, in 2006, reclassified as a dwarf planet. However, it's the only dwarf planet in front of the orbit of Neptune. Studies by NASA's Dawn spacecraft, which orbited Ceres from 2015 to 2018, have even found evidence of water, organic materials, and possibly even a subsurface ocean on Ceres, suggesting that the dwarf planet may have been geothermally active in the early days of the solar system. Subscribe to the channel now. There are many more exciting videos to come.